Now let's turn to complexity and pitfalls. First, we will read the cost of every operation in one table. Then we will look at the common C bugs, so you can spot them before they bite you. This table lists each operation, its time, and the reason you already saw. Let's read down the rows. Access by index is big. O of NA list has no address math. You must walk the chain to the ITH node. Search is big. O of N you scan the nodes one by one until you find the key or hit null. There is no midpoint to jump to. Traverse is big O of N. You make one visit per node. Insert at head is big O of 1. It is just 2 pointer writes and nothing shifts. Insert after a node P is also big O of 1. Again 2 pointer writes if you already hold P. Insert at the end with no tail pointer is big O of N. You must walk to the last node first, then make one link. Delete the first node is big O of 1. You move head and free one node. Delete by value is big O of N. The search for the node before it is the slow part. The relink itself is big O of 1. Now a learning check. You keep appending to a list you reach only through head. What does building an N element list this way cost, and what one extra field fixes it? Pause and think. Here is the answer. Each append walks to the tail, which is big O of N, so building the list this way costs 1 plus 2 plus up to N, which is big O of N squared. Caching a tail pointer makes each append big O of 1, and the whole build big O of N. This table has 3 columns. The mistake, the symptom you will see in the fix. Let's go through each bug. First mistake. You set head becomes X before you set X arrow next becomes head. Then the rest of the list is lost, and that is a leak. The fix is to link the new node first and move head last. Second mistake. You assign to a node pointer parameter inside the function. The caller's head never changes. The fix is to return the new head or take a node pointer to pointer. Third mistake. You read through a null pointer. For example, cur arrow next when cur is null. That crashes on an empty list or when you walk past the tail. The fix is to test cur is not null before you touch cur arrow anything. Fourth mistake. You free cur, then you read cur arrow next. That is a use after free. It crashes or gives you garbage. The fix is to save cur arrow next or relink before you call free. Fifth mistake. You forget to free a removed node or the whole list. That is a memory leak and it grows over time. The fix is one free per removed node and a list free call at the end. This is the classic linked list bug. You move head before you link the new node. The code still compiles and runs, but it quietly loses the rest of the list. Look at the buggy version. First it writes head becomes X, so head already points at the new node. Then it writes X arrow next becomes head. But head is X now, so the node points at itself. The old list is unreachable, that is a leak, and a walk will spin on X forever. Now the fixed version. It writes X arrow next becomes head first, while head still names the old first node. Then it returns X as the new head. The rule is simple. On any insert, write the new node's links before you overwrite the pointer that still names the old list.